So we're starting a new module. In this section, we're doing integration by parts. I remember when I was in Calc 2, this was one of my absolute favorites. I think Calc 2 is probably the most difficult one because you have so many formulas to learn. But once you start practicing them and doing them, then they become easier and just become part of who you are as you're doing them. So integration by parts, we need to recognize when we can use integration by parts, use the integration by parts formula to solve integration problems, and use the integration by parts formula for definite integrals. So our goal of this section of integration by parts is to compute an integral of the product of two functions. So I have something that looks like f of x times g of x, and I want to compute the integral of that. So some examples of that might be something that looks like, oh, I gotta get my screen to move. Give me a second. Screen don't want to move. Okay, there we go. Examples might be something that looks like the integral of x e to the x. That's a product of two functions. The integral of x squared times sine of x, again, product of two functions. And this is an odd case of when to use integration by parts, and we'll see how this comes into play. So let me derive for you the formula. Home. Okay, so I'm going to use U and V instead because that's what has been known to be used. Nobody uses F and G. You want to sit down, stabilize. Okay. So let's recall the product rule for differentiation. So the first thing we want to do is recall okay, so the product rule for differentiation was simply if I take the derivative with respect to x of a function f of x times a function g of x, that becomes the derivative of the first times the second plus the first times the derivative of the second. Okay, so that was the rule. All right, so I want to apply it to the product of u of x and v of x. Okay, so the derivative with respect to x of u of x times v of x dx. Nope, I don't want a dx there. Is equal to the derivative of the first u prime of x times the second v of x. And I just want the derivative. Yeah, I just want, yeah, the derivative. And we're going to use the differential. Yeah. So this becomes, oh, nope, I want it just like I had it. Let me just put it right back like I had it. I apologize. Getting ahead of myself. Don't want to get too fast. All right. And then plus u of x v prime. All right, so now what I want to do is I'm going to integrate that formula. Anybody have any questions so far? Okay, going to integrate this formula so I get the integral of the derivative that automatically, they're inverse functions, so you should know something's going on, of u of x times v of x dx. is equal to the integral of u prime of x, u prime, yep, v of x dx plus the integral of u of x, v prime of x dx. Now, the first thing we already said was that you integrate the derivative, you're just going to get a constant, actually. So the integral of the derivative will give you a constant. But in the meantime, I'm not going to worry about my constant. I'm just going to write this as u of x times v of x. And then over here, I want to write this as the integral of v of x, u prime of x dx plus the integral of u of x, v prime of x dx. So now, unbeknownst to you as of yet, this is what I'm trying to solve for. Why am I trying to solve for that? Okay, well, here we go. Let me add just a wee bit more space in here. And that is because when I solve for that, I'm going to let's switch to differentials. So we want to use the differentials. So I get u of x, v of x, minus, I'm sorry, equals, oh, I'm going to subtract it off. I may as well subtract the other one off right now. That's why, minus v of x. And then this differential right here, I'm going to call du. And then this is equal to what's on the left, on the right-hand side that's left, the integral of u of x. And this differential, I'm going to call dv. All right, so now I can rewrite it. As the integral of u dv is equal to u times v minus the integral of v du. And as you can see, that is what I have right here. And this is the formula.
Is this formula on the quick study guide?
I don't know. So that's the formula for integration by parts. All right, it's actually a very nice formula. It works very easily if you just do the formula. Okay, so I'll tell you this, most of everything that we've been learning this semester has been, here's a formula, memorize the formula, apply the formula. Here's the formula, memorize the formula, apply the formula. And I know you're thinking, my God, how many formulas are we going to have to learn? Well, we're just at the beginning. We're not, we have so many more formulas to learn. You need to practice them in order to be able to use them. So these are the examples that I plan to cover. The first 5 we should get through today. Okay, we should definitely get through the first 5 today, and then the last 2, which are more difficult, we will get through on tomorrow. Okay, first integral. Bring it on down. All right, so this is the first integral we're going to do. Very simple integral. The answer to the integral is not 1/2 x squared cosine x. You cannot just integrate one thing and integrate the other and multiply them. That will never work, and that will not give you a correct answer. Okay, so what you need to do is you need to identify u and identify dx, dv. So identify u and dv. That's the only thing, that's what you have to do. Okay, so u, 95% of these problems, u is going to be a polynomial or something whose derivatives go to 0 or get nicer. And v is whatever's left. There's a 5% of these problems where that rule does not work. And you will know that that rule does not work because you will get something even uglier than what you started with. And so we'll see something like that. Okay, so let's start this problem. So I'm going to let u equal x. So this is my u. And everything that's left has to be dv, because the problem has to be completely substituted for. And remember, the formula is the integral of u dv is uv minus the integral of v du. Okay, so we have u identified. We have dv identified. So now what we need to do is from this, we need to find dx, du, which is simply dx. And we need to find v, which means we integrate sine and we get negative cosine. And we don't have to worry about the constant because the constant falls out in the problem. Okay. All right, any questions so far? We identified u and we identified dv. Okay, so let's bring our integral on down here. So this now, so we already have u. So here's u. Okay, we have dv. Okay, so we need u, which is x, and we need v, which is negative cosine of x. So here we have u, and then we have v, and we need minus the integral of v, which is negative cosine of x, du, which is just dx. Now, this becomes equal to negative x cosine of x minus negative gives me a plus the integral of cosine of x dx, and the integral of cosine is sine. So now I get my thing is done. Integral of x, the sine of x dx was uv minus the integral of v du, which is sine of x. And I am completely done, so I add on my plus c. Okay, any questions?
You got the, how did you get the sin x? Is it just because you did the integral cosine, the derivative of cosine?
That's where I put it in. You're correct. Okay, any questions? Okay, next problem. Here's a problem where u again would be x because it's a nice function to differentiate. So what is dv?
E to the x
dx.
Good.
dx.
Thing that's left. Okay, what's du? That's dx. And the integral of e to the x is what?
E to the x.
Yes. Okay. So I have everything, u dv, du, and v. Once I get that, I'm set. Remember, an integral of u dv is equal to uv minus the integral of v du. Okay, so let's pull my integral down. What's u? X times v e to the x minus the integral of v e to the x du dx. Again, this is u, this is v. This is v du. This is u, that's dv. Everybody see that everything has a name. Nothing is left without a name. Everything has a name. Okay? So I get x e to the x dx is equal to x e to the x minus e to the x plus a constant. And there's the answer to my problem. Any questions? Okay, so I have a question. What happens if they gave me a definite integral? Something like this. Okay, so here's where we're going to use the fundamental theorem of calculus. Okay, so what's our function? Our function f of x is simply x e to the x. That's it. And our big F of x, which is most general antiderivative, I can write this, I don't use it, but I can write this as x times x minus 1 times e to the x. That's what that is, plus c. So its most general antiderivative is x minus 1 times e to the x. Okay, so I have a function, and then I integrated it and got its most general antiderivative. So the fundamental theorem of calculus says if I take this integral, I can take the antiderivative that we got, which is equal to x minus 1 e to the x, but it's evaluated from 0 to natural log of 4. So for integration by parts, I can complete my integral as such, and then plug in my limits of integration from the fundamental theorem of calculus. So the first piece is going to give me natural log of 4 minus 1 times e to the natural log of 4. And then I'm going to subtract off 0 minus 1 times e to the 0. Okay, what is e to the natural log of 4? Somebody quick.
Would it be E ln 4 times 1 to the 4?
Yeah, because I remember last time they did it, and I was like,
Okay, e and log are inverse functions. E to the natural log of anything is that thing. So e to the natural log of 4 is just that thing, 4.
4.
Yes. So I get log 4 minus 1 times e to the net, that's times 4 minus plus 1. That's what my answer is. So the integral, so notice now when you have a definite integral, you take what you got when you integrated by parts, and then you utilize the fundamental theorem of calculus. So as soon as I can find my mouse, there we go. So I'm going to write this out. This is equal to the natural log of 4 minus 1 times 4 plus 1. Uh-oh. Why don't I get an answer? Let's try it again. I'm trying to figure out why I don't get an answer. I got an answer in the other class. Okay, so let's see. I said 4 times natural log of, 4 times parentheses.
If I missed the test.
Natural log of 4.
No, I started at 1.
Plus 1.
Oh, where?
I forgot.
I still don't get an answer. That's weird. I got an answer last time. I don't know why I won't get one this time. I'm gonna try it one more time. 4 times, that's why I don't get an answer, because it thinks I'm in text mode. I just went. Okay, now, yes. 4, nope, wrong 4. Okay, that's why it's not working. 4 times the natural log of 4 minus 1 plus 1. There we go. That's the answer.
So on the test, are we gonna have to integrate that, or we are just gonna put it in the most simplest form?
This would be your answer on the test. Your answer on the test would be this. That would be it. On the test, you won't have a calculator, so you won't be able to do that. So your answer would be 4 times the natural log of 4 minus 1 plus 1. That would be your answer. And it's not a difficult answer either. I mean, you just leave it like that and you move on. Okay, so I've looked at x sine x, I've looked at x e to the x, I've looked at x e to the x as a definite integral. Now what I want to do is I want to bump that power of x up even more. So let's go to x squared. Okay. All righty, here we go. What's U?
X squared.
Yes. And DV is everything that's left. DU this time.
2x dx.
Mm-hmm. And V is equal to, we already know we're integrating, so we just get e to the x. Integral of U dV is equal to UV minus the integral of V du. Okay, so put my integral back. And I get equals U times V. So I'm going to get x squared times V is e to the x minus the integral of V, which is e to the x, du, which is 2x dx. Okay. So now I get the integral of x squared, e to the x dx is x squared e to the x minus 2 times the integral of x e to the x dx. Oh my goodness. Yeah. And so lo and behold, after all that work, I have the nerve to get down here to another integration by parts formula. Now, if I were on the test or in a homework problem, and my original problem was this x squared e to the x dx, I would then have to go and compute the integral of x e to the x dx, but I've already computed it just because that's what my notes work. So I've already computed it, and I know that it is somewhere. It is x e to the x minus e to the x. Okay, good. So I get the integral, oh, not red. The integral of x squared e to the x dx is equal to x squared minus, oh, forgot e to the x, minus 2 times, and in here I wrote x e to the x minus x minus e to the x plus c. So now the integral of x squared e to the x dx is going to be x squared e to the x minus 2x e to the x plus 2e to the x plus a constant, because I put in what I got from the previous integral. I'm lucky that we did that already. Okay, so far so good. Any questions? So with x equal to 1, u equal to x to the first power, 1 integration by parts. U equal to x squared, which is x to the second power. I got 2 integration by parts. So what do you think is going to happen with this one?
Three integration by parts.
Yeah, if I can find it. There it is. 3 integration by parts. That's a lot of work. Okay. All righty. U equal to x cubed du 3x squared dx dv, still e to the x dx, and v, still e to the x. So now I'm going to pull my integral down. This is going to equal u times v, x cubed times e to the x, minus the integral of v, which is e to the x, times du, which is 3x squared dx. Okay. The integral. No, that does not look like an integral. The integral of x cubed e to the x dx is equal to x cubed e to the x minus 3 times the integral of x squared e and e to the x dx. And again, oh my gosh, there it is, an integration by parts. So now if I have an x cubed e to the x or x cubed sine x, then I'm going to go down one and do an x cubed, x squared, and then I'm going to go down one and do. So I'm going each time for every power of x, I'm going to have an integration by parts. But luckily, we just did this one. Okay, we did. So we can put this in as the integral of x cubed e to the x dx. We're going to get x cubed e to the x minus 3 times x squared e to the x minus 2 x e to the x plus 2 e to the x plus a constant. Okay. So now we have the integral of x squared. Nope. Erase that. I so try to keep my notes neat. I cannot stand raggedy notes. X cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6 e to the x plus a constant. Okay, there we go. Okay. So far today, we've only learned one formula, one formula, but we've done several different problems using this one formula. Okay. So here's a new rule I want to teach you. And the new rule I want to teach you is the chart formula for integration by parts. And this only works when the integrand contains x to the n and n is a positive integer. Okay, if you're looking at x to the 1/2, not going to work. X to the anything else, not going to work because it's going to keep going. But you need something that as you take the derivatives go to 0. And that's a polynomial. Okay, so this is what we do.
Should we copy this chart?
I'm getting ready. Don't copy it yet. I'm going to walk you through it. And as we walk through it, we'll copy it. okay? I don't throw too much at you at one time that you have to run and copy down. So no, we're going to do one at a time. We're going to do this first one. Okay, we're not even doing these two yet. Those two are here for our next problems. Leave them alone. Okay, so we're going to do the integral of x squared cosine x dx. Okay, that's the one we're going to work on. Okay, we're going to do like the last problem. We're going to identify u. There it is. And identify dv. Uh-oh, that's the wrong problem. I don't need the dx for this part. I just need the function. Okay, so on the left-hand side, we are going to differentiate. See the d dx. So we start with x squared, derivative, 2x, derivative of 2x, 2, the derivative of 2, 0. Okay. Okay. On the right-hand side, we put in the dv function, which was cosine x. And now we integrate. So that's why there's an integral sign on the right-hand side. So we're going to integrate the cosine. When you integrate cosine, you get sine. When you integrate sine, you get negative cosine. When you integrate negative cosine, you get negative sine. So I only need to go until I match that 0. Any questions so far? I only need to go till I match the 0. So on the left side, I do different derivatives. On the right side, I do integrations. But this only works if u is x to the n. If it's anything else, this formula, do not use this formula. Do not. Okay, so.
I'm sorry, Dr. Luck. Is the exponent supposed to be a whole number?
It has to
u
be,
to the
it
x?
has, yes, it has to be an integer. The x, but it has to be x squared, x cubed, x to the 4th, x to the 5th, x to the 6th, x to the 7th, x to the 20th, whatever. But it cannot be a fraction or something negative. For this formula to work. But this formula does work and it's nice. And this formula will keep me from doing 2 integration by parts. Okay. All right. Now here's the tricky part. The square up here goes and meets the square one below. This square goes and meets the one below. And this square goes and meets the one below. So you have to cross multiply. So we're going to multiply x squared times sine x. We're going to multiply 2x by negative cosine x, and we're going to multiply 2 by negative sine x. Any questions? Okay, the last part. They alternate in sign. So this one is plus, this one is negative, this one is positive. All right, so we're ready. So the integral, leave it green, of x squared cosine of x dx is going to be positive x squared times the sine of x. It's going to be negative 2x times negative cosine x. Then it's going to be positive 2 times negative sine x. And now I'm done. So I'm going to add c. And now I get a final answer. The integral of x squared cosine of x dx is x squared sine x minus makes plus 2x cosine x minus 2 sine x plus a constant. Again, this only works if you have a power of x to, as Ezekiel said, a whole number. Okay, any questions? All right, now let's do this next one. That's why I said, don't just write down the whole charts and all that stuff. I will get you there. We're not ready. Uh-oh. Okay. Here's another one we're going to do. This one is the integral of x cubed e to the 2x dx. So here's the integral I'm trying to do. Okay, so u is equal to x cubed. So that already tells me I would have to do 3 integration by parts. I'd have to do one and then I'd get an integral with x squared. I'd do another one, then I'd get an integral with x. I would have 3 integrals to do. But if I use this formula, it's going to work out much nicer. dv is e to the 2x. So I'm going to constantly differentiate. So here's u. And we constantly differentiate u until we get to 0. So we do x cubed, 3x squared, 6x, 6, and then 0. Takes us 5 steps, but we get there. Okay, now the other side, you're integrating. That's why there's an integral symbol there. Okay, so we're integrating. All right, so we start off with e to the 2x. When we integrate it, we get 1/2 e to the 2x. We integrate it again. We get 1/4 e to the 2x. We integrate it again. We get 1/8 e to the 2. Last one, 1/16 e to the 2x. So those are all the integrations. Okay, differentiations on one side, integrations on the other side. Okay, so this is the dv. And this should be dx. So we need the dv function. All right, what do I do next? What do I do next? Who remembers from the last rule?
It's on the side, it's, you change it, it's positive, negative, positive, negative.
Okay. Good. Okay, what else did I do?
You match up the, well, actually some correspond to others. So like x cubed matches up with 1/2 e to the 2x.
Okay.
And then 3x squared goes to 1/4 e to the 2x.
Good.
6x matches 1/8 e to the 2x. And then 6
Good.
matches with 1/16 e to the
Okay.
2x.
I think we're ready to put it together. Thank you for all your help. Y'all really did good on this one. X cubed e to the 2x dx. Okay, so the first thing we do is positive. So that's x cubed times 1/2 e to the 2x. Second one's negative, 3x squared times 1/4 e to the 2x. Next one's positive, 6x times 1/8 e to the 2x. And the last one is negative, minus 6 times 1/16 e to the 2x. And then of course I'm done, so I get a constant. All right, y'all ready? Okay, so this is 1/2 x squared e to the 2x minus 3/4 x squared e to the 2x plus 3/4, that's 6/8 x e to the 2x minus 3/8, that's 6/16 e to the 2x plus my little humble constant at the end. Okay. So tomorrow we will pick up here and I will show you how to do repeated integration by parts, and I'll also show you how to do some other integration by parts formulas that are a little strange.
Dr. Lott, I think I missed attendance.
I was just getting ready to do it.
Oh, okay, I'm sorry.
Yep.